So, in this question, we are required to simplify without using a calculator, and we are given sine 120 times tan 300 all over cos of into negative 60 degrees times tan of 225 degrees. So now in this question, we're going to use what we call reduction. So this concept is called reduction, right? So reduction. So there's this Cartesian plane that will use in order to reduce this, right? So we have, remember, a three Cartesian plane has the x-axis and the y-axis, right? And then it starts from 0 degrees, and then we are moving anti-clockwise. So we have 90 degrees here, we have 180 degrees, 270 degrees, and then 360 degrees here. So now we're going to only use the x-axis. Remember, going this direction, the angle increases. So we are moving anti-clockwise. So from 180 degrees going this direction, we are increasing. So it's 180 degrees plus theta. And then also from moving 360 degrees after completing this circle going this direction, it's also 360 degrees plus theta, right? So now let's consider moving the other direction. Let's consider moving this direction. So from 180 degrees going this direction, it's 180 degrees minus theta, because the angles are decreasing now. We're moving against the increment of the angles. So we have 180 degrees minus theta, and then from this direction, from this angle, from 360 going clockwise, we have 360 degrees minus theta. So let us not forget cast, right? We have what you call a cast, which simply means that here all of them are positive on the first quadrant. On the second quadrant, only sine is positive, and on the third quadrant, only tan is positive, and on the fourth quadrant, only cos is positive. So we are going to use this. We're going to use this reduction diagram in order to solve this question. Okay, let's jump straight into solving this question now. So now, first step, we're going to look at sine. We're going to look at this angle here, 120, right? We can see that 120 is very close to 180. It's very much close to 180. So now we are going to use, remember 120, it's 180 being reduced by a certain angle. So we are going to use this reduction. Because it's 180 minus a certain angle. So we have to know this theta. How would you get this theta? You just punch your calculator. You'll say 180 minus this angle 120 equals to 60. So this angle is actually 60. So we're going to say sine of 180 degrees minus theta, which is 60. 180 minus 60 gives us 120 times tan. Now you can see that 300 is very close to 360, right? And it's being reduced. So we're going to use this reduction formula. So we're going to say 360 degrees minus. So what is our theta? 360 minus 60 gives us 300, right? Over. So this is 60. It's a special angle. So you're going to leave it like that. Cos of negative 60 degrees. And then now we can see 225. 225. It's very close to 180, but it's being increased. It's 180 degrees plus a certain angle. So we have to see we have to check what is that theta. So we punch our calculator. We're going to say 180 degrees minus 225, getting 45. So it's going to be times tan of 180 degrees plus 45 degrees. So that's how you apply this reduction diagram in order to solve for this question. So now we are going to use the reduction in order to check the signs now, right? So let's look at sine. Sine of 180 minus theta falls on the second quadrant. This is the first quadrant, this is the second quadrant, right? And this is the third, and this is the fourth. So 180 degrees minus 60 falls on 180 minus theta, and then sine is positive. So this will be reduced to sine of 60 degrees, which is positive, times tan of 360 minus 60. Sine of 360 degrees minus 60. So 360 minus theta falls on the fourth quadrant where only cos is positive. So tan will be negative. Tan will be negative. So we have negative tan of 60 all over cos of a negative angle. So negative angles. So let's look at negative angles. We didn't discuss what are negative angles. So remember here, I told you about the 0 degrees, right? I told you about the 0 degrees. So going this direction, now let me use another color. Let me use this color. So going this direction, it's going to increase, right? We are moving anti-clockwise. So it's going to be 0 degrees plus theta, right? Which is equals to theta, right? So it's basically theta, right? So now, going this direction, it's actually 0 degrees minus theta, right? So basically here, this is equals to negative theta, right? And then negative theta falls on the fourth quadrant, right? It falls on the fourth quadrant, so whereby only cos is positive. So if here we had sine of negative 60 degrees, it was going to be negative because it falls on the fourth quadrant whereby only cos is positive. So on the fourth quadrant, only cos is positive. So now, just know that this actually simplifies that. Sine of negative theta will be negative sine of theta, and then tan of negative theta will be negative tan of theta, and then cos of negative theta will be positive. Because remember, on the fourth quadrant, only cos is positive, so sine and tan will be negative. Hence, we can see here, sine and tan, they are all negative. So now, let us change this. This will be positive cos of 60 degrees. And then now, let's look at 180 degrees plus theta. 180 degrees plus theta. Tan is positive. It's on the third quadrant. Tan is positive. So we're going to say times tan of 45 degrees. Right. Now, let's look at special angles. So probably you guys know a little more about special angles. So let me just erase this. So now, let us talk about special angles. Special angles. So I'm going to draw the special triangles for us to use, and these triangles, you have to know them, right? So let us start with the first triangle. So we are going to draw an equilateral triangle with all sides that are equal. Remember, an equilateral triangle has all sides equal and all angles equal, right? So this is an equilateral triangle, and then all sides will be equals to 2 units, right? So after drawing this equilateral triangle here, so I'm going to divide it. So this side will be perpendicular. I'm going to divide it equally, and then this side will have a 30 degrees, and this side will also have a 30 degrees. So I'll just remove one side of a triangle and remain with the other one. So I'm going to take this side of this triangle. I'm just going to take this side of this triangle. So I'm going to draw it. I'm going to draw it here. This side of this triangle. So we'll have 2 units like this, And then remember we divided this sides equally, so we had this long side equals to 2. Now we'll have 1 unit here and 1 unit here. So now this side here will be equals to 1 unit. And then now we have this side here. And then we'll have 30 degrees here. And then we'll have 60 degrees here. So remember we removed one side of the triangle, remaining with that. So I'm just going to do this. Just going to do that. So now, remember this is the hypotenuse side, this is the hypotenuse side, and this is the adjacent side x, and then we are looking for y. So theorem of Pythagoras, you're going to use the theorem of Pythagoras. You're going to say r squared is equals to x squared plus y squared, and then we have 2 squared equals to 1 squared plus y squared, and then we have 4 minus 1 equals to y squared equals to 3, therefore y is equals to plus or minus the root of 3. So remember here we are dealing with units or a distance. Remember a distance can never be negative, so therefore y is equals to root of 3 units. So you can never say a distance from here to Cape Town is negative 3 units. So, or negative 3 kilometers or negative 100 and something kilometers. So that's highly impossible. So distance is always measured in positive units, unless if you considered going to the left or going to the right as the negative direction. Remember, displacement and distance, they are not the same thing. A displacement is a vector quantity, but distance it's a scalar quantity. So there's a difference between a vector and a scalar. So units, whenever something that says units, it means it's a distance. It has a unit of distance. So now distance can never be negative. So therefore here we'll have root of 3. So now we have a complete diagram of our special angles. We have 30 degrees and 60 degrees. So now we are going to use this special angle to find sine of 60 degrees. So we have to find sine of 60 degrees here. Sine of 60, remember sine is opposite over hypotenuse. So we're going to use this angle here. So the opposite side of this angle here is this one. So the opposite side is root of 3 over, the hypotenuse side is 2. So it's root of 3 over 2 times into negative, and then tan of 60 degrees, tan is opposite over adjacent, so the opposite is root of 3 over 1, which is root of 3 over 1, and then cos of 60 degrees is adjacent, which is 1 over hypotenuse, so it's 1 over 2 times, now we have another special angle 45. So remember we are done with the special triangle. So let's erase this. So now let's look at another special triangle. So we have another special triangle. So I'm going to draw it here. This one is an isosceles triangle and also a right angle triangle. So it has a 90 degrees here, and then this side equals to this side, right? If we have 90 degrees here, if you are supposed to find the other two sides, remember, if we can see here it's x and here it's x, you already know that x plus 90 degrees is equals to 180, right? And then we're going to take the 90 degrees to the right hand side, giving us 180 degrees minus 90 degrees equals to x plus x. X plus x is 2x, and then 180 degrees minus 90 degrees is equals to 90 degrees, which is equals to 2x. Dividing by 2x on both sides, x will be equals to 45 degrees. So now here this special triangle has this angle and this angle, which they are both equals to 45 degrees. So we have 45 degrees here and then another 45 degrees here, right? So now We are also given that this side is equals to 1 unit, and then also this side will be also equals to 1 unit, and then we don't have r, so we have to find r. So remember, this is y, this is x, we don't have the hypotenuse side, r. So finding r, we're going to use the theorem of Pythagoras. R squared is equals to x squared plus y squared. So our x is 1 squared plus our y is 1 squared, which is equals to 1 plus 1, which is equals to 2. Therefore, r is equals to plus or minus the root of 2. So remember, the unit can never be negative, hence we explained. So therefore here we'll have a root of 2 units. So this is another special triangle that we're going to use. Whenever you see 45 degrees, we are going to use this special triangle. So now, using this special triangle, we'll know that tan going to SOHCAHTOA its opposite, the opposite side is x. The opposite of 45 degrees, we can see that x is the opposite side. Remember, opposite is the side that's facing is facing the angle, right? This is the opposite side of this angle, which is 1 over the adjacent side. So the adjacent side of the same angle, of the same 45 degrees, will be this one. Remember, it's adjacent to this angle, so it's 1 over 1, which is equals to 1. So now, continuing from here, we can simplify this. So root of 3 times root of 3 gives us 3. So this is going to be negative 3 over 2. And then 1 over 2 times 1 is equals to 1 over 2. And then this is negative 3 over 2 divided by 1 over 2, which is equals to, we're going to change this into multiplication. So negative 3 over 2 times 2 over 1. So this will cancel that, which is equals to negative 3.